Chapter 9. The Storm Drain. Storm drain is that unit of the plumbing system that conveys rain or storm water to a suitable terminal. Storm water is normally discharged into street gutter conveyed by public drain system and carried to some natural drainage terminal like canal, rivers, lakes, and the like. As a general rule, storm drain is not permitted to discharge into a septic tank or to the main sewer line. The collection and disposal of storm water is an important phase of plumbing system that should not be ignored. Otherwise, water coming from the roof, if not properly diverted, might create problems like 1. Settlement of the structure caused by erosion or washing away the soil from the foundation. 2. Subjecting the basement floor and walls to unnecessary groundwater pressure and possible leakage. 3. Rundown water may create walls and window leakage. 4. Water may spill on people passing by or approaching entry door. 5. Erode the surrounding grounds and cause disfiguring of the landscape area. The disposal of storm water has been a major concern of the local and national government. Large amount of the appropriation is regularly incorporated in the annual budget for the drainage purposes. Among the government's priority program on infrastructure is toward flood control. The trend is to provide a storm sewer line to serve not only the commercial and industrial establishments, but also residential houses in disposing of storm water. Laws and ordinances were passed making the connection of the storm drain to the storm sewer line compulsory. A splash pan is a collector of water coming down from the downspout, leading the accumulated water away from the house at a relatively low rate of flow. Figure 9:1 shows the detail of splash pan. 2. Classification of storm drain. Storm drain is classified into three types. 1. The inside storm drain. 2. Outside storm drain. 3. Overhead storm drain. The inside storm drain is sometimes located under the basement floor or within the wall of the building. This type of storm drain is commonly found in buildings constructed along congested business district or building that occupies the entire frontage of the lot. The drain pipe is laid under the floor or walls of the structure. For large building, storm drain are laid in two or more lines to convey not only the water coming from the roof, but also those water accumulated from the inside court of an open area toward the street gutter or public storm drain. Figure 9:2 shows the detail of inside storm drain. The outside storm drain is installed outside the foundation wall of the building. This type of drainage is possible on location where the lot is not totally occupied by the building. Figure 9:3 shows the detail of outside storm drain. The overhead storm drain is adopted when the street drainage is higher in elevation than the basement floor of the building. The purpose is to avail the gravity flow of water. The pipe is well fitted and suspended inside the ceiling by suitable hanger spaced at closer intervals. 3. Size of a storm drain. The size of a storm drain is determined under the following considerations. 1. Gauging the rainfall over a given period, whether it is constant or exceedingly heavy shower of short duration. 2. Consider the varying roof areas, the slope, and the distance of water traveled before it reaches the conductors of the roof. 3. Water drain faster on high-pitch roof. 4. Water drain faster on high-pitch roof. Hinge requires a larger drainage pipe than that of a flat roof. 4. The height of the building contributes largely to the velocity of water falling inside the vertical pipe conductor. The velocity fall accelerates the flow of water entering into the storm drain. Table 9:1 shows the size of a storm drain. 5. The use of improper fitting and short offsets that will affect the flow of water must be avoided. The conservative estimate of maximum rainfall in the Philippines is about 20 mm in a 5-minute interval. Using this data, the approximate volume of water that will be accumulated on the roof in 1 minute can be readily computed using Table 9:1, Size of a Storm Drain. Figure 9:4 shows the size of the roof leader. Illustration 9:1. What size of a storm drain is adequate to serve a roof having a slope of 2% with the general dimensions of 20 by 30 meters? Solution 1. Solve for the roof area. Area is equals to 20 times 30 equals to 600 square meters. 2. Refer to Table 9:1. Under 2% slope, 600 square meter is within the limit of 700 square meter roof area, which could be served effectively by a 150 mm pipe diameter. Comments. From illustration 9:2, it appears that a roof A required a 100 mm pipe diameter and 75 mm for a roof B. If only one roof leader will be installed in each roof, considering the 20 meters length of the gutter, the rainwater has to travel a long way before it reaches the roof terminal. Under such condition, the gutter might be overloaded and overflow is likely to occur. 2. The standard practice is to provide 2 or more terminals for a roof leader to avoid clogging and overflow. The fount size of the pipe is installed on 2 terminals would be oversized and expensive. Thus, it is necessary to select 2 smaller pipe with a hole area equivalent to 100 mm and 75 diameter, respectively. Solution 1. The 100 mm or 4-inch diameter as found has a cross-sectional area of a circle is equals to 0.7854 times diameter squared. Area is equals to 0.7854 times 4 squared is equals to 12.56 square inch. 2. Divide into 2 terminal is equals to 6.28 square inch. 3. The gross sectional area of a 75 mm or 3-inch is 7.06 inches squared, greater than 6.28. Therefore, specify 2 pieces 75 mm diameter pipe. Second solution. 1. Area of roof A is equals to 200 square meter. 2. Divide by 2 terminals is equals to 100 square meter. 3. Refer to Table 9:2. The 100 square meter area is within the parameter of 76 and 165 square meter. Therefore, specify 2 pieces 75 mm diameter pipe. For roof area B, it is equals to 160 square meters. 5. Divide by 2 terminal is equals to 80 square meter. 6. Refer to table 9-2, 75 mm pipe is sufficient. 7. Specify 2 pieces 75 mm downspout for roof B. Figure 9-7 shows the exposed and concealed type of roof leader. Table 9-3 shows the combined storm and sanitary drain. End of Chapter 9. Chapter 10. Traps for plumbing fixtures. 1. Trap. A trap used on plumbing fixture is a device scientifically designed to prevent the backflow of gases coming from the septic tank or sewer line passing through the outlet of the fixture. These gases are identified as hydrogen, hydrogen sulfide, methane or carbon dioxide, and even a small amount of carbon monoxide considered dangerous to human health. The physical and chemical properties of the many gases found in the sewage system are known and their effect on human body is sometimes serious. The basic function of the trap in a drainage system is to prevent those objectionable gases from entering the plumbing system. The principle is to form a mechanical barrier against the passage of sewer air. In 1856, when the first patented trap in the United States are innovated, manufacturers offered various forms and designs to the plumbing industry. Tests of these traps shown that the most practical form ever developed is the P-trap. Originally, this P-trap was called gooseneck, attributed to its form like the neck of a goose. Analyzing the mechanical function of a P-trap, it appears that the only separation between the unhealthy gases in the sanitary drainage system and the air inside the room is the water caught in the trap every after discharge of the fixture. The column of the water that is retained between the overflow and the dip of the trap is called trap seal, or sometimes referred to as water seal. Water-sealed P-trap is classified into two. 1. The common seal. 2. The deep seal. The common seal P-trap has 5 cm deep water seal between the overflow and the deep that will offer resistance against abnormal conditions. Only to the amount of pressure a 5 cm water will develop. The deep seal P-trap has from 7.5 to 10 centimeters column of liquid content between the overflow and the deep. This trap may be used under normal conditions, but it is purposely designed for abnormal situations such as A. Extreme heat condition in the area. B. Increase and decrease of atmospheric condition. C. Circumstances where total ventilation cannot be obtained. Figure 10-1 shows nomenclature of a P-trap. One advantage of the deep seal over the common seal is its greater resealing quality. Reseal is term used to the scientific principle that water and rest tend to seek a level and maintain it. When the liquid content of a deep seal is disturbed, the water tends to level itself sufficiently to seal the trap even partially, meaning because of the considerable height of the water seal, up to 10 cm deep, even if disturbed by flushing from the fixture discharge by a partially sealing up to 50%, the trap seal is still maintained. The P-trap is the most common and practical shape available in various sizes, from 72 mm to 50 mm diameter. These are common sizes for fixtures that are suspended from wall or supported on a pedestal such as 1. Lavatories, 2. Sinks, 3. Shower bath with less than amount of water discharge, 4. Urinals, 5. Drinking fountain. There are various forms of water-sealed trap that could be used to serve plumbing fixtures, but among these various types, some are classified as permissible trap, while others are identified as objectionable trap. Figure 10:2 shows type of permissible traps. The permissible type of traps: 1. The P-trap, 2. The drum trap. Other type of permissible traps: 1. Stand trap, 2. Brass trap, 3. High hub trap, 4. Low hub trap, 5. Extra heavy type, 6. Sink or lavatory type. Objectionable traps that are found defective: 1. The full-size S and the 1/3 S trap, 2. The bag traps, 3. Mechanically sealed traps, 4. Light metal partition traps. Figure 10:3 shows objectionable traps. 2. P-trap installation. The National Plumbing Code on P-trap installation provides that 1. All trap shall be self-cleaning, that is capable of being completely flushed each time the trap operates, and no sediment will remain inside to decompose. 2. P-trap shall be installed as near the fixture as practical, not to require too long vertical leg between the trap and the fixture proper. 3. Short vertical leg eliminates high velocity of water discharge that creates siphon, the major cause of trap seal loss. 4. P-trap shall be installed within 60 centimeters of the fixture it serves. It shall be accessible for cleaning through the bottom opening closed by a screw plug. 5. All traps are subject to stoppage, hence shall be provided with clean-out so designed that could be assembled and deassembled with little efforts. 6. Long-run horizontal pipe could be used only near the drain of the floor area or yard. It is also called running trap, not provided with hand hole clean-out. Figure 10:4 shows P-trap installation. 7. The deep portion of the trap shall be as short as possible to avoid retarded flow of water. Likewise, the horizontal leg connection to the waste pipe shall be reasonably short for effective ventilation. 8. Overflow pipe from the fixture shall be connected to the inlet side of the trap. 9. Each fixture shall have its own trap. The following fixtures are exceptions to the rule: A. 2 laundry tray and the kitchen sink connected to a single trap. B. Not more than 3 laundry tray using one trap. 3. 3 lavatories on a single trap. 3. Drum trap. Drum trap is also classified as a water seal device. The name was derived from its size being large in diameter. It has the following special features. 1. Drum trap is intended for fixtures that are set on the floor like bathtub, foot and seat bath, and other similar fixtures. Figure 10 to 5 shows type of drum trap. 2. Drum trap is used on fixtures that discharges substantial amount of water. It is effective where trap seal loss is more prevalent due to the velocity of the flow and short intervals. 3. Drum trap can also serve as terminal for soda fountains, bar waste, and any type of indirect waste. 4. Drum trap has two types. A. The 100 mm by 125 mm and B. The 100 mm by 200 mm. Figure 10 to 6 shows the installation of drum trap. Advantages of the drum trap. 1. Greater amount of water may pass through it in a short interval without the danger of trap seal loss. 2. It has a higher resealing quality than the P-trap. Disadvantages of the drum trap. 1. It is large and cumbersome. 2. It is unsightly if the installation is exposed to view. 3. Clean-out cover mechanism is above the water seal. 4. To clean the drum trap needs lubricant and a fiber washer at the joint between the cover and the body of the trap. Table 10 to 1 shows the minimum size of fixture trap in millimeter. The National Plumbing Code on traps provides that every trap shall be self-cleaning. Traps for bathtub, lavatories, sink, and other similar fixture shall be either lead, brass, cast iron, galvanized, porcelain, or enameled inside or plastic. Traps were required. Each fixture shall be separately trapped by a water-sealed trap placed as possible to the fixture, except that a set of similar fixture consisting of not more than 3 wash basins, or a set of 3 laundry trays, or a set of 3 sinks may connect with a single trap, but in no case shall the waste from bathtub or other fixture discharge into a water closet trap. No fixture shall be double trapped. 4. Size of fixture trap. The National Plumbing Code has regulated the minimum diameter of trap and drain to be installed. Likewise, the size of the pipe drain depends upon the class of users the installation will serve. And the minimum size of the trap and waste branch for a specified fixture shall confront to the values given in Table 10 to 1. Fixture to be installed are classified into 3. 1. Class 1 for private use, like fixtures in residential houses, apartment and private bathroom of hotels, and similar installation. 2. Class 2 for semi-public use, applied to fixture in office building, factories, dormitories, and the like for occupants' use only. 3. Class 3 for public use, such as schools, gymnasium, hotels, railroads, and bus terminals, public comfort rooms, and other installation where several fixtures are installed for unrestricted use. Table 9-2 shows the minimum trap and drain diameter in millimeter. Section 56. Traps, kind, and minimum size of recommended minimum requirement state that every trap shall be self-cleaning. Traps for bathtub, lavatories, sink, and other similar fixture shall be made of lead, brass, cast iron, or of malleable iron galvanized, porcelain enamel inside or plastic pipes. Traps shall have a full bore smooth interior waterway with threads of solid materials of the same kind. The nominal size or inside diameter of trap and waste branch for a given fixture shall not be less than the given in Table 10:1, which is the minimum size of fixture trap. All traps are subject to stoppage, hence must be provided with a clean out, are so designed that they can be disassembled with little effort. Continued discharge of greasy waste reduced the diameter of the pipe, and no benefit can be expected of the trap when these natural phenomena occur. Plumbing system that is well constructed cannot be depended upon to give satisfactory service over a long period. Therefore, the installation must be positive and remain so during its expected life to be effective. End of chapter 10.